Welcome to Web Handling. My name is Dave Roysam. I am super excited to continue our new series on best practices. In this week's show, we will describe a few best practices for the most common controls on web machines. They are called the TNTs of control. A brief mention of application and calibration is also included. I know your time is precious, so let's get started. It would be eye-opening to count every single dial, knob, switch, and valve on your machines. These are the control inputs that are manipulated by operators and maintenance to run a machine. It would be eye-opening to count every single analog and digital meter. These are the outputs that inform the operator and maintenance how the machine is running. There could be 100 control inputs and readouts on even a simple small winder. This would be as complex as a light aircraft. There can be hundreds and hundreds of control inputs and readouts on a laminator. This is similar to what you would find in a small jet. It is no wonder that operators and maintenance and engineers alike can all feel lost. Despite the complexity and variation among the web machines of all colors and stripes, you will find some common ground with the essentials. These essentials are found on nearly every web machine and are known as the TNTs of web control. The first T stands for tension. The N stands for nip. The other letters depend on the machine you are referring to. On winders, the last T stands for center surface wind torque differential, and the little s stands for speed. Not all winders have those wound roll tightness controls. On other machines, the last T stands for temperature, which is by far the most important control when a machine has that control. Winders and other machines are also often concerned with path control, which includes such things as guiding, wound roll edge quality, and registration. We will not discuss these items that are asterisks because they are techy and covered elsewhere, and because they are less common. Here, we will just focus on tension and nip because they are ever present. Tension control is ubiquitous on all machines of all colors and all stripes and all flavors. Yet, despite this immense variation, there are some near universal concerns. The first is that the tension set point in a drive zone is often set between 1/10 to 1/4 of the web's strength. It is an economic optimization between high tension defects such as wet damage and low tension defects such as poor web stability and flatness. Thus, it is vital to make a strong effort to ensure that tension controls are well managed in your plant. That means that, like almost all controls, tension needs to be periodically calibrated, but always in engineering units, as opposed to some peculiar units that are often found on some machines. That means that more than a few people need to go to web school to understand what tension is and how to set it. That means that at least a few people need to go to drive school, because it is motors that often do the tension control work. And this is a specialized expertise that takes years, if not decades, to develop. In many ways, NIP is similar to tension in that periodic calibration is also needed here, and also in engineering units instead of machine particular units. However, NIP calibration must also include measurements of system friction. We show how to do this in my web school and on this all web handling channel of YouTube. What varies widely is the amount of NIP load that is used. It can vary from less than 1/10 of 1 pound per inch of width on tissue winders to more than 2 tons per inch on currency printers to even more on metal rolling. If a machine temperature is elevated, such as on extruders, calendars, ovens, and the like, it is almost always one of the most important controls in your plant. 2 things are important. First is the optimum temperature set point, which is very application dependent. The second is often neglected, and that is the temperature uniformity across the width. However, for more than a few machines which do not have elevated temperatures, mere environmental temperature and humidity can be important for a few select web and winding problems. The other common control need is to control the path of the web that is needed for trim waste reduction, waste due to misregistration, and wound roll edge quality and wrinkling, and more. This topic again is well covered in my school and in the literature. Thank you so very much for joining me in this Best Practices mini-series. Join me next week where we will talk about a few best practices for plant operations and management. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.